Hi, everybody, people of my class. My name is Christian Rico. They are tutor and they are classmates. Today, I will share to you my solution of the task 2. The first exercise tells us that an electromagnetic wave with power of 100 travels through the air in N1 377 ohms and collides perpendicularly on a plane wall of intrinsic impedance N2. In the following table, calculate the reflected power P1 but minus and the transmitted power P2 plus from different values of N2. So this exercise is just a table that we have to fill with the information that they give us to us. And N1 is the R intrinsic impedance in ohms. N2 is the wall intrinsic impedance in ohms. So we just change N2 for we can see the results. For example, the reflection coefficient has this form, and we got these results. The percent of reflectance changed with the different N2, transmitted, reflected power, and transmitted power. We got all the solution. But the most important is that we got the transmitted power to the wall. You can see it in this table when I got a resistance of 159. I got this power. When I have a resistance of 477, we have this power. And when we got a 954, we got this impedance. So we can see that when I have a very less impedances in ohms, I have this value of transmitted power. When I have too much, I have a less value. And when I have a very less. So when I got more, it's in the middle. In the second point, we got an electromagnetic wave of frequency in 44 megahertz, and P plus 100 is estimated by a generator through the air, and air is equal to 377, and collides perpendicular on a wall of intrinsic impedance, and wall is equal to 69, and they have 10 centimeters thick. This is the wall, and this is the generation. So the exercise one that we calculate the coefficient of reflection and transmission, same by the generation, and determine the percent and the power of PT, that is the total power that is transmitted to the receiver. So in the input impedance, we got a beta is equal to omega and air sobre CO and wall. Omega is equal to 2p and the frequency. So we got the results in radians under meters. We can see the calculus. Then N in is the impedance that into the receiver. So we got the form, and we just have to replace the values, and we got the GeoGebra evidence. Reflection coefficient 1, we got again this is the form, this is the, so we just have to replace the transmitted one, we just have to replace, and they give us a percentage of transmittance. That's what the exercise that we do. Transmission coefficient 1, we got the form, we have to replace it, and finally the reflectances, and we just have to replace, and we got a 61.9%. We got the GeoGebra evidence. Then we got to do twice, but with different data, because this is the air against the wall. So when we got this, we're going to have two T's, that is to transmit. So we're going to see what is the total transmitted power, and it's just by the multiplication. So we got a 0.1994, that is actually the 19.94%. We call look the GeoGebra evidence. The transmitted power is just PT plus, it just multiplies the power with the total transmitted, and we got this power. The theory exercise tells us that an electromagnetic wave propagates through several medium as shown in the graph. We could see glass, air. We have a wave, and the wave is get in another direction because of glass, and we got 2 angles. This exercise wants us to find what is this angle, what is this angle, what is this angle, what is this angle, to get the angle B. So we got the impedance of the R of the glass and the R again because we got R glass R. So the first thing that we have to do is to find the angle number 1. The angle number 1 you can get by lessing by 90 degrees less angle E, and angle E is actually 39.5 degrees. So we got that the angle 1 is 15.5 degrees. This is what the Snell law tells us. N1 multiplied by sin of angle 1 is equal to N2 multiplied by sin of angle 2. We just have to make an, like I said, a reorganization, and we got that the angle 2 is equal to sin elevate to minus 1 multiplied by N1 under N2 per multiplied sin of the angle 1, and we have a result. The angle 2 is 30.52 degrees. If we do this 2 more times, we're going to get the angle 3 and the angle 4. And to get the angle B, we just have to take 90 degrees and less the angle 4. And we got that the last angle is the angle B that actually values 39.5 degrees. That's all for the video. I really hope that you enjoyed.